Good morning. I'm Jeff Davis, Executive Director of the MSU Alumni Association. I'd like to welcome our viewing audience this morning to Bulldog Bites, our virtual speaker series featuring Mississippi State faculty, staff, researchers, and alumni. Today's installment of Bulldog Bites, the Atlantic hurricane season, looking back on 2020 and looking ahead to 2021. We're pleased this morning to have Dr. Kim Wood, who is Assistant Professor in the Department of Geosciences here at MSU, specializing in tropical meteorology. She obtained her PhD in atmospheric science from the University of Arizona in 2012. She's participated in two field campaigns, tropical cyclone structure in 2008 and genesis and rapid intensification processes in 2010, as well as two international workshops, the International Workshop on Extratropical Transition in 2012 and the International Workshop of Tropical Cyclones in 2014. Dr. Wood has published and presented on research that includes land impacts of tropical cyclones in the eastern northern Pacific Basin, extratropical transition of tropical cyclones, satellite-derived estimates of tropical cyclone genesis and intensity, and quantification of environmental factors that affect tropical cyclone structure and intensity. She's currently pursuing research related to tropical climatology, land impacts of tropical cyclones, and tropical extratropical interaction events. Dr. Wood, good morning to you, and thanks for sharing your morning with us, and welcome to Bulldog Bites.
Thank you so much for that introduction. I'm really happy to be here. I'm honored to get this chance to talk about what I do and how we think about just what happened in 2020 in the North Atlantic, and looking ahead to 2021, what we might expect this year. So I want to touch base on a few things, make sure we're all on the same page for what I'm talking about, and then dive into some of the work I've done to look at just what we can learn from what happened last year. So looking back on 2020, we broke numerous records. There were more named storms than what we observed in 2005. There were quite a few landfalls, and the number of impacts across the Atlantic basin was quite high, exacerbated by complications from a pandemic. So what exactly happened? What broke records? And what might that mean moving forward? Well, to make sure we're all on the same page for what I'm talking about when I refer to hurricanes, sometimes you might hear them called tropical cyclones. A tropical cyclone is the generic name for a tropical storm, a hurricane, or a typhoon. Depending on where they are in the world, they get these different names like hurricane or typhoon, but the generic name is tropical cyclone. So if you ever hear the term tropical cyclone, such as a potential tropical cyclone, that's referring to a storm that something like the NHC, National Hurricane Center, would monitor. And if it gets strong enough, it would get named. So these systems form over the oceans. They like warm water, much like we would if we wanted to go to the beach. And once that storm reaches 39 miles per hour for its maximum sustained winds, that's when it becomes a tropical storm. That's when it would get named. So any storm that reaches that 39 mile per hour threshold is what we would call a named storm. Once they get stronger, if they reach at least 74 miles per hour, that's when they would be labeled a hurricane. And if they reach wind speeds of at least 111 miles per hour, that's when they get that major hurricane designation related to the Saffir-Simpson hurricane wind scale of category. So a major hurricane is a category 3 or higher storm. Again, that specifically refers to the strongest winds, which would occur near the center of the storm. The whole storm doesn't have those strong winds. It's as you get closer to the center, that's where you tend to see the strongest winds in a storm. That's how we categorize them. In 2020, we had 30 named storms. This is a map that I made here at Mississippi State showing all of the tracks of these storms as monitored by the National Hurricane Center during the season. And the colors have to do with how strong they were or what kind of storm they were at that time. So anytime you see the oranges or the reds, that indicates it's a hurricane or major hurricane. And then the sort of cooler colors indicate that it's a less strong of a storm. So we can get a sense of not only where did all these storms go, but also what intensity were they in that area. And it kind of stands out that there was a lot of activity in the Caribbean and the Gulf of Mexico. For context, 2020 produced 30. The previous record was 28 named storms. That was set in 2005. 14 of these 30 named storms became hurricanes, and 6 of them became major hurricanes. So we have 6 storms out there that have parts of their track that are red. That indicates the part of their life cycle where they were at least 111 miles per hour. One of the downsides of having so many named storms is that increases the likelihood of landfall. And in 2020 in particular, the United States got hit a lot. There were 11 storms that made landfall, destroying the previous record of 9. And this is just in the continental United States. There were many other storms that made landfall elsewhere, such as both Eta and Iota making landfall very, very close together in the same place about 2 weeks apart in Nicaragua. So this record here is just for what hit the US. That doesn't include all the landfalls that occurred outside of the US. We also used some new names. They came from the Greek naming list because we ran out of names from the traditional list. And so never before, nor never again, and I'll talk about that in a bit, will we name any storm in the Atlantic Eta, Theta, or Iota. So these had never been used prior to 2020, and they won't be used again. We can also take a look at just how busy the season was in the sense of how much was happening at the same time or very close together. This is a timeline showing all of our named storms. We've got the time on the horizontal bar here, and this vertical dashed line indicates the typical start of the hurricane season, which is June 1st. From this timeline, we see that Arthur and Bertha both occurred prior to June 1st. So the official start of the hurricane season was after the first and even second named storm that we observed in 2020. Also, when we see these names overlap, that indicates the storms were happening at the same time. The boxed region here shows a very, very active September. In fact, it was so active that Wilfred, Alpha, and Beta were named within 6 hours of each other. That hasn't happened before. So it wasn't just active in the sense of the number of named storms, but also the clustering of activity was incredibly unusual. So 2020 is going to stick around in the record books for some time to come. Like I showed before on that big map, it was a busy season in the Gulf of Mexico. We had 11 named storms make landfall in the US, but we also had multiple storms in the Gulf of Mexico itself make landfall as hurricanes. This is an example of Hurricane Hannah from July, which you may have forgotten by now because July feels like a very long time ago in the context of the 2020 season. We had Hurricane Laura make landfall in Louisiana as a Category 4 storm, and Hurricane Delta made landfall less than 15 miles away 6 weeks later. So not only did we have a lot of storms, but they tended to impact the same places. Louisiana in particular was affected by 5 different storms in 2020. We also had Hurricane Sally, which some of you may have either personally experienced or knew people who experienced it due to the fact that it affected southern Mississippi, southern Alabama, and the Florida Panhandle. And we also had Hurricane Zeta, again, making landfall in Louisiana. This storm moved very, very quickly. And because it moved so fast, it didn't have time to sort of spin down as it moved over land, which means that its strong winds went really far inland and caused a swath of power outages ranging into Georgia. So Mississippi, Alabama, Florida, and Georgia, as well as Louisiana, were negatively impacted by this storm's winds, resulting in widespread power outages. Looking ahead to 2021 and beyond, we will not be using Greek letter names anymore. 2005 and 2020 each used Greek letters to name storms once the typical naming list had been exhausted, because usually we don't run out of names. But it could be confusing, especially if we have to retire names. It's weird to retire Greek letters. So we will officially no longer use Greek letter names. In fact, Instead, we won't use them at all. We are going to have a rotating backup list of names that resemble, but of course are not the same as our usual lists. And we'll pick from that if we run out of names. We don't expect to run out of names this year, but it is something that is changing moving forward. We will no longer use Greek letter names to name our storms. Also, the National Hurricane Center routinely issues outlooks, kind of like your local National Weather Service forecast of, we'll have this kind of weather coming up, but for the tropics. Usually they start issuing it for the Atlantic on June 1st, but this year they're going to start on May 15th because we've been seeing these increasing frequency of storms forming prior to that official start of June 1st. Also, every 10 years, NOAA will take a look at what's been going on in the past 30 years and revise their 30-year or long-term averages. And so by now having gone through 2020, we can update our 30-year average from the 1981 to 2010 period to the 1991 to 2020 period. And that shows an increase in what we consider the average activity in the Atlantic. So we've gone from 12 to 14 named storms, 6 to 7 hurricanes, and stayed about the same at 3 major hurricanes. So this is the point of reference that we'll be using moving forward for what we consider an average Atlantic hurricane season. What could happen in 2021? The experts have started issuing their long-term outlooks for what might happen. The folks at Colorado State are the best in the business, and they are looking at an above average season, even compared to these updated normals. So right now, as of what we know for what is currently going on, such as El Nino, what's currently going on in the Atlantic, they're expecting 17 named storms, 8 hurricanes, and 4 major hurricanes. But I want to remind you that it just takes one storm for it to be a busy season for you. So coming up soon, we've got Hurricane Preparedness Week, where we'll be talking about all kinds of things that you can do to understand what kind of information comes out about hurricanes, what you can do to prepare now if you live anywhere near the coast, and what you should do if a hurricane does end up developing and potentially could impact your area. I, again, want to emphasize it just takes one. So it could be a below normal season compared to these numbers, but if that storm happens to affect you, it's a busy season for you. So this is the time to review what types of preparedness you can do for your area, to ask questions, and to think about what might be coming up in the future.
Great, thank you so much, Dr. Wood. We'll move into the Q&A portion at this point. So we know storms are named. So the question submitted is, what is the actual naming process and how are those names actually selected?
That is a wonderful question because it's easy to find the names. It's not as easy to find the process of getting those names. So the World Meteorological Organization, the WMO, meets on a regular basis to assess what types of names we could use, whether any of those names should be retired, and if they're retired, what names should be brought in next. So countries submit names for consideration. They need to be in alphabetical order because we do this alternating A, B, C, D thing. And there is a bit of a gender inclusion where traditionally female names alternate with traditionally male names. So if you read through the list, you'll see that A might be more male, B might be more female, and so on and so forth. And then it alternates each year. So this committee that's part of the WMO will meet to assess what names are reasonable from those that are submitted, and do they follow these conventions, and are they something that won't cause offense in some ways. For example, in the Eastern North Pacific, there used to be names such as Adolf and ISIS, but due to associations such as Adolf Hitler or the organization ISIS, those names were replaced by ones that had less potentially negative connotations. So names could be removed both for those reasons as well as for retirement reasons.
So in your review of 2020, there was multiple occasions where multiple storms hit kind of a very specific close area. What is the biggest reason or factor that Was it temperatures of water at the time? Was it other pressure systems that kind of steered it? What was the most contributing factors to that?
So when a storm forms, there's 6 what we call ingredients to create a tropical cyclone. And one of those is a pre-existing disturbance, some sort of cluster of thunderstorms that could spin up into a tropical cyclone. A source for those thunderstorms is Africa. They're called African easterly waves, and they come off Africa on a fairly regular basis. And in 2020, many of those waves went across the Atlantic and got into the Caribbean. And when they got to the Caribbean, they found warmer waters, more moisture, that sort of thing to help them spin up. So the fact that they tended to spin up once they got to the Caribbean meant that the general flow of the atmosphere tended to steer them in similar directions. So the pattern that was in place for Hurricane Eta was very similar to the pattern in place when Hurricane Iota formed 2 weeks later that sort of steered it the same direction. They also both moved over very warm water that was very deep warm water. So Eta wasn't enough to churn up that energy and thus reduce what Iota had, unfortunately.
There's a question regarding kind of storm surge and kind of what that exactly is and what it means.
So storm surge, I'm glad you asked because I have a slide about that. So storm surge is defined as the extra water that comes ashore on top of what tide we would expect. So if the tide is coming in, then you're going to get even more water on top of that. If the tide is going out, storm surge is still technically the same, but the total amount of water that comes in is lower. So the worst timing for storm surge is when the tide is also coming in, because that brings in some water already, and then we have the surge on top of that. So storm surge is the amount of water that comes in above what we expected in the first place. And the things that can affect storm surge include what I mentioned as far as the tide timing, but also the slope of the ocean floor coming up to the coast, how the shape of the coastline itself, and how quickly the storm is moving and how big the storm is. A bigger storm will push more water onshore.
And isn't Mississippi prone to worse surge based upon that depth and slope of our coast?
Yeah, there's not a lot of natural barriers to help break up the surge as it comes in, and the shape of the coastline along with the slope of the ocean floor coming up to our beaches will make storm surge worse.
A question regarding hurricanes or cyclones and their ability to form or not on land.
Ooh, yes. So to make a tropical cyclone, you need lots and lots of warm water, because warm water is one of the sources of energy for the thunderstorms. But thunderstorms can form over land. So why can't hurricanes form over land? There's not enough energy. We need a lot of energy spread out over a large area to power the whole storm rather than just one bubbling upward sort of column of thunderstorms. Also, there's an element of friction. So if you're over water, the surface is relatively smooth, but if you're over land, the wind is going to hit trees and hills and houses and that sort of thing, which will remove energy from the wind that thus isn't going into the storm. So the presence of friction over land tends to reduce how much of the energy that's present goes into spinning the storm up. So between not having enough energy in the form of the warm water and the friction, you don't get those storms over land.
Another question regarding interaction with land. What about the landfall of a hurricane kind of slows the hurricane down or affects the intensity? What is it specifically?
So when it comes to hurricanes making landfall, I've prepared a couple animations. This is looking at the storm from space using satellites, specifically the GOES-16 satellite. So what we're going to do is we're going to follow the storm as it approaches land. So this is Hurricane Sally We're seeing it pulsing and organizing, and it's moving pretty slowly because we're following the storm. So just sort of spun offshore. Everyone in Alabama is like, where are you going to go? And finally, it makes landfall. So you see if we go back to here, the storm looks pretty circular, especially right there where you've got the warmer eye and the colder cloud tops. It looks kind of like a donut. That indicates a mature, well-organized hurricane. But then as it moves over land, so right here is the coastline, you'll notice that it loses that nice circular shape. So it spins like that, and then look how much less circular it is as it moves onshore. That has to do with the difference in friction and available energy between when the storm was over the water and when the storm was over land. So as they move over land, they become more asymmetric, they've lost their energy, but it still takes some time for them to spin down. So their strong winds can still extend far inland. So even though it looks like this at this point, it's still a 60 knot, 65-ish mile per hour tropical cyclone. If they're moving more slowly, that will change how much they interact with land versus if they're moving more quickly. So if we look here at Hurricane Delta, note that it's moving much more quickly through the Gulf of Mexico, because these are looking at same timeframes, and then it becomes extremely asymmetric as it hits land, as it quickly moves over that shift from being over water to being over land.
And lastly, I grew up in Houston and have lived in Mississippi, Alabama, all hurricane states for sure. It seems to me, not only over a long period of time, but even a shorter period of time, the cones of uncertainty and the models have gotten so much better and more accurate. What I know data plays a large part in that, but what exactly has led to such a more accurate prediction, especially that 3 to 5 day out? It seems like that has tremendously gotten more accurate. Kind of tell us a little bit about why that is and what all goes into that.
So when we want to forecast what a storm will do, we want to look at as full a picture as possible. So our computer models provide part of that picture. They take in our available data for the current picture of the atmosphere and look forward in time to see how, compared to now, what might change and how can we use that to interpret what the storm will do. So that's a big part of why things have improved. Our computer models have gotten better. Our computers themselves have gotten faster, they've got more memory, and thus they're able to do more complex calculations over smaller areas to capture more of the detail that are affecting these storms. So as you saw from those animations, the storm itself is big, but there's a lot of nuances in sort of the shape of the eye and eye wall, that sort of thing. And if our models have higher resolution, they're better able to capture those nuances of how the storm structure is changing and thus do a better job forecasting what the storm will do. Our data themselves have gotten better. So we've got satellites with increased capabilities. The pictures I was showing were snapshots every 5 to 10 minutes. We used to get snapshots every 30 minutes. So when we have more information over the same amount of time, that's more that our models can work with. We have more observations on land, and other satellites that orbit the Earth closer to the surface are giving us profiles of what the atmosphere is like. So how's the temperature changing with height? How's the moisture changing with height? And all of that gives our models a better initial picture to forecast from. Also, our understanding of these storms has improved. So you mentioned when you introduced me some of the field campaigns that get done to fly into storms and learn more about them. Yes, I have flown through a hurricane. I want to do it again. It's safe, I promise, because we're pretty high up. But the information we get about the storm structure is on such a fine scale compared to what our models or even our satellites can capture. And so we're better able to understand how is this rising motion here versus the structure of the storm here related to what the storm's currently doing and what it might do next. So part of my research strongly examines what does a storm do when it moves into different types of environments? Is the air drier or more moist? Is the ocean warmer or cooler? That sort of thing. Because if we can better understand the processes that affect the storm when it moves that way, we can better predict what the next storm that moves into something like that will do. So our understanding of the processes inside a storm have improved, our computing capabilities have improved, and our observations have improved. But at the end of the day, it comes down to the forecaster. So we also have incredibly skilled people working at places like the National Hurricane Center. And not only are they working very hard on the sort of science physics side, but also how do we communicate this to people who aren't hurricane experts so that they know what to do if they're in the path of a storm. So that's another element that's improved, how we tell others about what the forecast means and what action items they should take. That's why I mentioned the upcoming Hurricane Preparedness Week. Using, your plan that you've thought about ahead of time means that you can then build from that point to interpret something that could be related to a hurricane coming in the next, 1, 3, or 5 days.
So last question, what about tropical cyclones and your specialty? What was kind of the draw for you to go into this area of specialization?
So it's hard to pinpoint one thing. I'm fascinated by the atmosphere being a fluid, but the one point that I think back to is I was a teenager and I went to an air show and they had a hurricane hunter crew at the air show. And I got to wander the plane and talk to them about what they did and the uses for their data and their observations and that sort of thing. And right then I was like, I guess I need to go to not just undergrad, but grad school so that I can study hurricanes. So my background started in physics and then I moved to atmospheric science. And now I study tropical meteorology. So I really wanted to get in with the data, the observations, connect that to the models, the processes, and of course, the communication of that to folks like you guys who are interested in this sort of thing.
Fantastic. Well, Dr. Wood, thank you so much for sharing some time with us this morning. We're very fortunate to have you here at Mississippi State. Thanks for everyone for tuning in to this edition of Bulldog Bites, and we'll see you next time on the next edition of Bulldog Bites. Have a great day and hail state.
Hail State.